Okay, so basically, if you're trying to have the answer to question D, which I think is the hardest question, you're first gonna want to identify your variables. And I wrote this wrong, so for me, you can pick whatever variables you want, but for me, I'm gonna do this is y and this is x, because that's just how I remember it. So basically, to start it off, we need to identify our slope, because that's what the question asks. So we take a graph and we try to figure out our slope. So I picked this point and this point, 2 points that fall on the line perfectly, basically perfectly. So I counted the x values and I got a delta x as 14. And then I counted this and I got 30 billion. But I can't just write 30 billion. I have to put it into scientific notation so it will be an actual number. But at the same time, I don't want to actually write 30 billion, because that's going to be so many zeros. So I just write it as 3 times 10 to the power of 10. So that's our delta y. Your line of best fit will be different than mine, so don't use these exact numbers, but just use the same scientific notation and use the same ideas. So basically, I figured out my slope. It's delta y over delta x. I don't know why I wrote it there. Yeah, delta y over delta x. And so that means my slope will be 3 times 10 to the power of 10 over 14. That's my slope. And now we go back to the question, and I figured out my slope. So from there, we just write our equation. So I'm going to write the equation down. Y equals ax plus b. A is our slope. So we're going to do y equals 3 times 10 to the power of 10 over 14 times x plus b. And the question is asking us to figure out b, which is our y-intercept. And so to figure out b, we have to identify on y and x value. So if we go back to our graph and we find a good point on the line, I found this point right here. It has a y value of 45 billion right here and an x value of 2014. So to figure out what the point looks like, we have to first, again, use scientific notation. So we go over here, 45 billion equals, where did I write that down? 4.5 times 10 to the power, 4.5 times 10 to the power of 10. So we figured out what our y-axis value, so let's just write that, y, and then 4.5 times 10 to the power of 10. And now we have to figure out our x value. So you'd probably just think it's 2014, but it's actually not, because our x is number of years since 2005. So 2014 is how many years since 2005? 9 years. So our x value is equal to 9. So that's 9, 4.5 times 10 to the power of 10. So then we go back to the equation that we're writing, and we know that hold on, where did I write that again? Okay, so we know that our y value is 4.5 times 10 to the power of 10. Yeah, equals 3 times 10 to the power of 10 over 14. And then we go to our x, which is 9 over 1 because we're multiplying, plus b. And then this is where it gets a little bit tricky because you're like, wait, how do I figure this out? So I'm going to get my calculator. I'll be right back. Okay. Got my calculator. And we're just going to figure this out. We're going to figure out b. It's a bunch of big numbers, and it's going to be fun. Okay, so first we have to multiply 3 times 10 to the power of 10 times 9 and 14 over times 1. So let's write this over again. Equals 3 times 10 to the power of 10 times 9 over 14 plus b. And I don't want to leave this as a fraction. I want it to be a whole number. So we're going to do everything times 14. So this is 4.5 times 10 to the power of 10 times 14 equals 3 times 10 to the power of 10 times 9 plus 14b. And now I want to get everything that's not a b onto this side. So what are we going to do? We're going that was really weird. We're going to minus all of this, or minus all of this, because there's a plus sign right here. And the opposite of plus is minus. So minus 3 times 10 to the power of 10 times 9. Let's move it on to this side. 3 times 10 to the power of 10 times 9. So let's do 4.5 times 10 to the power of 10 times 14 minus 3 times 10. Okay. 4.5 times 10 to the power of 10 times 14 minus 3 times 10 to the power of 10 times 9 equals 14b. Now is just a big bunch of mess of numbers. So let's figure out 4.5 times 14. 4.5 times 14 is 63. Yeah. So 63 times 10 to the power of 10 minus, let's do 3 times 9. 3 times 9 is 27. 27 times 10 to the power of 10 equals 14b. But scientific notation, you can't have 2-digit numbers. You have to have everything like in front of the decimal has to be between 1 and 9. So we're going to do times 10 to the power of 11 for both. 2.7 times 10 to the power of 11 equals 14b. Just so it's simplified and it makes more sense in scientific notation wise. So now we're going to look at this and I'm going to say, wait, because they're the same number, you can just do 6.3 minus 2.7 and you get 3.6. So then it's just 3.6 times 10 to the power of 11 equals 14b. And to figure out b, we just divide each side by 14. And honestly, you can't put 14 into either of those. So that is just your b value. You figured it out. 3.6 times 10 to the power of 11 over 14 equals b. That's the b value. We figured it out. And if you want to actually figure out what that means, what that looks like on the graph, we're going to look at where my predicted y-intercept is, and it looks to be about 25 billion. So let's put this into our calculators and see what we get. So 3.6 times 10 to the power of 11, okay, divided by 14. That's 2.57, so that's 2.571 times 10 to the power of 10. And I already know what that is, because 10 to the power of 10 means a billion. So that means that my predicted value is right. It's 25.71 billion. So we did get it right. So now if you just do all of that, but with your own numbers and your own line of best fit, you'll get the predicted b value. And you can leave it like this, or you can turn it into this to make it look more like a billion. That's how you do it, and if you need any more help, just ask me.